Hello, thank you for joining us. I'm going to be looking at a solution to one activity. I've got this activity on my whiteboard. And the activity states ripples are formed on the surface of water when an object lands on the surface. Let the initial height of waves start at 4 centimeters above the calm level position. We could also call that the mean position. And let there be an 80% reduction in height each time. And let the time between waves be 0.1 seconds. So the period of waves, which was 2 pi on b for our trig formulas, is 0.1. And we're asked to show the graph of the vibrations of heights as a trig curve. Start at 4 centimeters, show the first 6 vibrations. Okay, so let's do that. I can move this up. All right. So let's draw a y-axis. Now I'm going to let every 4 increment, if I've got enough room. I might not. All right, I might have to just let every 2 increments. Okay, that'll do. I want the first 6 waves. And I want my initial height to, say, be 4. This is centimeters. And first cycle, 0.1 seconds. Every 0.1 second, we have a full cycle. And that's time in seconds. All right, let's just get a different color here. Now, I believe we were told that there's 80% subsequent height. So the first height starts at 4 centimeters. And then it's going to be 0.8 of 4. So 0.8 times 4, 48%. 0.8 times 4, it's going to be a height of 3.2 at 0.1 seconds. Now times that 0.8 times 3.2, 2.56. So it's going to be 2.56 at 2 times that by 0.8, 2.04 times that by 0.8, 1.6 times that by 0.8, about 1.3 times that by 0.8, about 1.04. Okay. Well, I'll just put roughly between these height. It's lost a bit of space here. Between that height and this height, it would have lost some height halfway. Here it would have almost 2. Here it's a bit below 2. Oh, sorry. Let's go back. It's the wrong position. I want it here. and it's losing height. So a trigonometric curve, it's going to cross at the quarter of a cycle. It'll cross at 0, and then we can draw our graph. It's only approximate. There's some damping going on, losing energy. As the waves go along the water surface, the ripples slowly disappear. Each time the height is lost due to energy. Okay, that will do. See, it's cos curve that's coming down. Show the graph of the derivative of those heights. Okay. So let's do that on a separate graph. This time we have a 0 height, so it's 0 here, still 0.1 second, and it's turning. Every time it turns, it's turning on the x, so it's a 0 value. The derivative is 0 at the turning points. So these are the 0 values. 0.6, 0.5, 0.4, 0.3, 0.2, 0.1. And it would have been approximately the same amplitudes. And we're losing height each time. This is a negative graph, so it's a negative slope. It's going to be a positive slope, negative slope, positive slope, negative slope. Oh, I've been putting these in the wrong position, so I'll just cross back to here. Positive slope, negative slope, positive slope, negative slope, positive slope, negative slope, positive slope. Okay. Negative. And you can see it's like a sine curve this time, but it's a negative sine curve because the derivative of cos is negative sine. Okay, we'll finish it. All right. Time, seconds. That's f of, that was p of x, wasn't it? Oh no, we haven't been told yet. Okay. So this is just derivative. Okay, let's go back, have a look at the third one. Let P of X be 4 times 1/8 negative 0.5092. Graph this function. State the value of P of 0. Okay, do I have Casio function? I'll just check. How do I check? See if my Casio function's working. Don't know if this subscription is valid. No, continue with my current version. Will it work? Not sure. Have to have faith that it's opening in the background. Meanwhile, I'll put that onto my calculator as U tan 2 in the graph function y equals 4. Now, negative 0.5092. Oh, that's actually wrong. Can I? No, I don't want it to be negative. Let me change that. Sorry about this. Because we've already got 8 to the negative 1, this is an 8th. If I have that to negative, it's going to be back to be positive 8. Yeah, I want each time for it to get bigger by an 8th, so I need a positive index in that position. That was an error on my part. Never mind, let's put that in the, I'll just change that. Okay, looks like Casio graph didn't open. Oh yes, it did, there it is. All right, so let's go to graph and let's delete these ones, clear all. Yep, okay. Now I want 4 times 1/80. Do I have an 80 or an 8 in that position? Sorry about this. I'm going to change that to 80. That's a small adjustment. You can change that very easily. I did change that, but I forgot to change it on the master copy. But okay. It needs to be 80. Let's go back to the function. 1/80 to the power of 0.5092246x. Okay, let's sketch that graph. Really? Maybe it should be an R. No, that X should be up here. All right, that's better. Now, edit. Let's go to adjust the scales. I want the X minimum to be 0. I want the X maximum to be, say, 1, and I want steps of 0.1 because every second. All right. I want my Y minimum to be, say, negative. Doesn't matter. I want my Y maximum to be, because it starts at 4, I'll start my Y maximum at 5. Okay, there we go. Okay, here we've got the graph we want. Okay, so that's the graph we have to plot. Notice it starts out at 0, 4. I'm going to just trace this and see my x. All right, if I plot at different points, and if I can move that not so easily, no, I've got to. All right, save time. When x is 0.5, y is 1.3. Okay, so let's go back to our whiteboard and sketch that graph. It started out at I'm going to put 0.1 here, 0.2, 0.3, 0.4, 0.5, 0.6. It starts out at 4. 0.5 it was 1.3. And if you look at the heights of each time, let's go back to the graph. I'm going to get a list. That really doesn't help me. I want 0.1. Let's go back. I have to like to let's go back to the graph. I wonder if I can. If I copy that, Control copy that, go back to main menu, clear all that. And if I define f of, say, x as that, okay, now I want f of 0.1 is 3.2. So 3.2, is that right? That was too high. F of 0.2 2.56 2.56. See these heights here? You might recall 0.8 of. Let me just go back to the original calculations that I had before. 0.8 times, I use my standard calculator, 4 times 0.8 was 3.2, times 0.8 was 2.56, times 0.8 was 2. So you will see that these heights here correlate. You can check that. 1.6, 1.28, and about 1. Oh, so you basically have to try to draw that. I think this point here is slightly too high. All right. Good. Where is it? Okay, so we've graphed this. State the value of P of 0. Can I do that up here? P of 0 is 4 times 1 on 80 times 0.509224 times 0, which is 4 times 1 over 80 to the power of 0, which is 4 times 1, which is 4. Anything to the power of 0 is 1. And that's this value here. All right. Power of 0, function of 0 is equal to 4. That's the coordinate 0, 4. Okay. What is the amplitude of this function? 2 pi over b is the amplitude. B is 20 pi. So the pi's cancel, and you've got 1/10. You will see that that correlates with our story, where our period is, 1 second. Plot the graph of r of x. Now, r of x is equal to p of x, which was that function we just graphed, 5092246x, times by cos of 20 pi x. Okay. You can plot that on your, you can go to your calculator, go to graph if you want, put in, I might just adjust this and times this by cos of, is it 20? I wonder if it works with pi. 20 times pi times, hang on, 20 times, I'll use that. I could just do 20 pi x. Oh, okay, that should work. Scale this up to be y minimum of, say, -5. And let's sketch that. And there you go. I think we've already sketched one of these. And I think I can quite safely say, if you were to look very carefully, here is the graph of that function. That was from our story, and appropriately we've got the amplitude function as p of x and the cos curve as q of x. Notice that r of x is the amplitude form, the formula for the amplitude each time. Now, on the same set of axes, plot the following. K of x is 4 times the 8th dx. This is not the derivative of x. This is simply a constant d. Now, d can change. First of all, we want d as positive. Then we want d of 0, and then we want d of negative. You see, we've got a negative value up here anyway. So we've already got a graph using a negative, don't we? That was, this graph here is like K3 of x, where where d is less than 0. If you remember correctly, that graph was 4 times 1 over 80. Just got to change that to an 80. Sorry about that. Otherwise, it doesn't match our story. Uh, 1 over 80. And we had negative 0.5092246x. Now, if we go back to the graph, and I'll just delete that again, sketch that graph. All right, that's a negative. Let me just check. Oh, no, that's a positive. No, that's because we've got a D. That's the positive, isn't it? Because 80 to the negative 1 is 1 over 80. So if we had 4 times 80 to the negative 0.5092246x, that's the same as 4 times 1 over 80 to the positive 0.5092246. So this is a case of damping that gets less and less and less, where energy loses, the energy lost causes the reduction in height. All right, so I'll change that. That's when D is in fact positive. We'll just change that. That's when D is positive. We've done that one. Okay, so we've done the first one. Let's go back to the graph and put a 0 value in there. Let's put a 0 value here. 0 times D. Sketch that. And it's a straight line. Okay. I may as well change the color because I can. This is k2 of x, d equals 0. Because we've got times 0, that's just to the power of 0. That'll be like 4 times 1 over 80 to the power of 0x, which is 4 times 1. And we go to the graph and we change this to a negative. Let's just use same number, similar. Okay, let's get a graph of that. I've got to change my axes. I need a greater y value. Let's change the y value up to 20. And it's going up like this. Okay. What was it looking like? All right. All right, so this is k of 3 of x when d was a negative. Now be careful, because notice our value here is a fraction. So when we have a fraction here, when the fraction is less than 1, if you have a positive number, if you have a negative number, you're inversing the fraction. Mhm. And that is the first part of these ripple effects. I hope this has helped. Let me just zoom out so we can freeze frame on this. And I hope this has helped. Until we talk again, stay happy.